प्रॉब्लम क्या है? योर कलेक्शन बहुत लो है। क्या बोल रहा हूँ, तुम्हारा कलेक्शन बहुत कम है। तुम्हारा कलेक्शन बहुत कम है। क्या मैं सीडी कितना है तेरा? मतलब सीडी कितना है?
Good afternoon for Australia. Good morning for India, US. Good evening for India. Today's topic is limits and continuity. This is the 7th lecture or session 7 of Padma Shri Dr. SR Valluri Memorial Lecture Series. It is held on all Saturdays from 6 p.m. to 8 p.m. as per Indian Standard Time. This is a virtual program through Zoom. All are welcome irrespective of their geographical locations. Thanks to Corona for having made this possible. The topic for discussion for the Zoom meeting on today, the Saturday, 22nd January 2022, from 6 p.m. to 8 p.m. as per Indian Standard Time is limits and continuity. Learn free from any place. Learn free at any time. Learn free at any pace. This is an Atmanirbhar Bharata initiative. The program is called as lecture series. However, wherever possible, discussion method will be utilized to the extent possible for exchange of ideas among the participants, including but not limited to the speaker, for the purpose of encouraging everybody in terms of thinking, learning, problem solving, and understanding the topic of interest. The resulting multiple point of view is expected to help to build better knowledge, understanding, and interpretation of information and topic discussed. This day, that year, there was a conference on a technical subject. It was in an engineering college that was spread over 2 days. During the conference, the principal of the college stated that several parents and guardians approach him on a regular basis and ask for the best branch of study to admit the dependents or students which does not require mathematics, as their children dependents are weak in mathematics. In addition, several viewers of this lecture series have requested that engineering mathematics may please be taught under the series of free lectures, keeping in mind the best interest of the students who get admission to the engineering colleges and polytechnics, who are the so-called students who are weak in mathematics. Although the students admitted to engineering colleges actually passed the prescribed subjects in Standard 12 or pre-university or pre-engineering courses, obtaining the minimum marks required as per the applicable admission and reservation policy, most of the students find it extremely difficult to understand the degree level mathematics starting from the very first class which they attend in the institution. This is because of the simple reason that somehow they could get the minimum marks needed in the qualifying examinations, sufficient enough to get admission to engineering colleges, polytechnics, institutions, but they actually do not have sufficient background in the subject of mathematics, and they really do not know from where to start and in what direction to proceed. To understand degree level mathematics taught in engineering colleges, institutions, deemed universities, deemed to be universities, etc. To provide sufficient background that is necessary and sufficient to start with to understand engineering mathematics and to proceed with learning the engineering mathematics that is actually prescribed or and taught in engineering or educational institutions. The free lessons are designed keeping in mind the best interest of the students. The learning of mathematics under this series is made as simple as possible so that those who feel that mathematics is difficult for them to study and understand will be able to change their own opinion and say why some people are telling that mathematics is a difficult subject when it is so easy to learn, easy to remember, easy to practice, and even easy to score higher marks in qualifying examinations. How to start and when to start learning engineering mathematics, which is nothing but the use of mathematics for the solution of problems in engineering applications. The answer is here and now. Where there is a will, there are several million ways. Everything that is conceived and believed in the mind can be achieved with great ease. Then let us start the first forward step in learning engineering mathematics. Welcome, viewers. Let us start from understanding information or data related to learning engineering mathematics. Data is used both as singular form and also plural form. It represents information. Data or information contains letters, digits, and special characters. In this lesson, the letters used are alphabets of English language. Digits are the decimal digits used in decimal number system, and the special characters which include but not limited to all other characters available on a standard keyboard other than letters and digits. We use English language only. In the alphabets of English language, there are 26 starting from A to Z. There are two main types. One is called uppercase letters. Uppercase letters are also known as capital letters and sometimes known as big letters. The computer generated uppercase letters are shown in the slide from A to Z. In handwriting, the styles vary from one person to another person. Therefore, the letters may have slightly different appearance. What is shown in the screen? They are computer generated characters for handwriting style, one of the handwriting styles. Another style of handwriting style from computer generated characters is shown in the screen. Actual writing may slightly vary from one person to another person. The lowercase letters are also 26 starting from A to Z. The computer generated letters are shown on the screen. The lowercase letters are also known as small letters. In handwriting style, which varies from person to person, can also be seen on the screen. The handwriting style varies from person to person, and there are several handwriting styles available in the computer also. The decimal digits are, deci means exactly 10, and therefore there are 10 different digits or symbols used to represent the decimal digits in the decimal number system, and they are from 0 to 9. The handwriting style also varies from person to person when writing the decimal digits. This is another handwriting style which is available in the computer. In the computer, there are many handwriting styles are available for writing any message. Here, there is a sample of a particular type of the handwriting style. So here, let us see what is written in this message. Now, everybody can email everything that they think to somebody or anybody and everybody else, either knowing or not knowing the fact that nobody reads them in these days of high science and high technology, as they are otherwise extremely busy. Everybody either sit down or even while walking or standing do the emails in the morning or evening or afternoon, perhaps with a similar diligence as that with which they have typed the letters. In the early days of computer use, somebody reprimanded for writing emails as if they were letters. Apparently, the inappropriate formality and the inappropriate use of the media put horrific pressure on the recipients. Nobody will respond in kind, as they are too busy to really read all that message contained in the email. Somebody still keep the emails in a letter size like form. It is not uncommon to wonder anybody get reprimanded for it by somebody or nobody. After all, everybody, somebody, anybody and nobody all belong to a family. The actual handwriting written varies. It is a sample is shown here, which may be a little difficult to understand depending on the style of writing followed by the writer. Special characters. Some of the characters which we will be using or we may require their use are shown here. This is not the exact list. As and when we require additional symbols, if at all we require, we will introduce them while proceeding with the lessons. The special characters also vary in shape and size depending on the style of handwriting that is used. Typical samples are shown here on the screen. In addition to mathematical symbols, we also use several Greek letters for representing different pieces of information or data in mathematics. The style of writing the Greek letters alpha, beta, gamma, delta, etc. also vary from person to person. Some typical forms are shown on the screen. As a reminder, the topic for discussion for the Zoom meeting on today, the Saturday, 22nd January 2022, from 6 p.m. to 8 p.m. as per Indian Standard Time, is limits and continuity. Learn free from any place, learn free at any time, learn free at any place. This is an Atmanirbhara Bharata initiative. The first chapter that is generally included in the textbooks on differential calculus is known as limits and continuity. In this topic, several basic definitions, ideas are covered. The most important, necessary, and sufficient definitions and terminology which are essential to learn the subject of differential calculus are explained in this chapter or topic on limits and continuity. So let us start the topic on limits and continuity. The several basic building blocks of this topic are discussed in this lesson. One of the important data or information is known as constant. One of the dictionary meaning of a constant is a number that is assumed not to change value in a given mathematical discussion. I do not know how many people will understand by just this definition. This is one of the definitions given in the dictionary. So the best thing to have on the idea of constants is to look at some examples. For example, see the figures 9.81, 9.8, 10.0, 32.2, 981. If you remember, all these values represent what is known as acceleration due to gravity, represented by usually the letter G. G is acceleration due to gravity. Actually, acceleration due to gravity is not a constant, but it varies from one place to another place, and also it changes from time to time. That is, acceleration due to gravity at the poles is greater than the value of acceleration due to gravity at the equator, because Earth is a partly flattened sphere. In most of the problems given in examinations, the value of G will be given as 9.81 meter per second square. But there are some question papers where they will say use the value of G as 9.8 meter per second square. There are also some question papers in which they will say use the value of G as 10 meter per second square, because it will help in simplifying the calculations. In the foot-pound second system, commonly known as FPS system, the value of G is 32.2 feet per second square. Similarly, the value of G used in centimeter gram second system or CGS system is 981 centimeter per second square. Now, for writing the formula in a convenient form, instead of writing the specific values such as 9.81, 9.8, 10, 32.2 or 981. Generally, we use the letter G, a small letter G. So depending on the units of measurement that we have to use while solving or simplifying mathematical expressions related to a problem, we substitute corresponding value of G, treating that the average value of G on the surface of the earth can be treated as a constant without making much difference. Another example of constant is we come across something like 3.14, 3.142, 3.1415, 3.1415926536, 3.1415926535, 8979, 3238, 4626, etc. etc. What is this number? This number is indicated by using the Greek letter pi. So the value of pi is the ratio of circumference of a circle to its diameter. That means pi is equal to circumference of the circle divided by the diameter of the circle. Here, the value of pi is approximated and used as 22/7 for simplifying calculations while solving problems. Another example of constant is the number like 2.718, 2.71828, 2.71828, 2.7182818, 459045, etc. This number is represented by the letter E. E is the base of natural logarithm. So E value can be written for several number of decimal places like 2.718, 28, 18, 28, 45, 90, 45, etc. Now, because we have used the term something called logarithm, we'll try to understand what is logarithm of a given number. The logarithm of a given number y to a given base a is the number x to which the base a is to be raised to make it equal to the given number y. This is approximately the definition of the logarithm of a given number in words and sentences. Now let us see how to write it in the form of a mathematical symbol. Now we will write log of the number y to the base a as shown in the slide here. See here, we will write log, slightly above we write y, and below we write a. Read it as log of y to the base a. It is equal to x. That means this y is equal to this base a to the power x written like this. Y is a power x. So log y to the base a, if it is can be written as x, then y is equal to a to the power of x. A is the base of the logarithm and x is the log of the given number y. Common logarithm of a given number y is to the base is taken as 10 in case of common logarithm. Is the number x to which the base 10 is to be raised to make it equal to the given number y. So in the writing, we write log y to the base 10 is equal to x. That means y is equal to 10 to the power of x. So here this 10 to the power of x is also known as anti-log of x to the base 10. So y is equal to 10 power x means y is equal to anti-log of x to the base 10. There is another type of logarithm which is used in mathematics, that is known as natural logarithm. Natural logarithm of a given number y to the base e is the number x to which the base e is to be raised to make it equal to the given number. So if the base is 10 here, it is called common logarithm. If it is e, it is called the natural logarithm. So in the writing, we write log y to the base e is equal to x like this. This means y is equal to e to the power of x. So e is the base of the logarithm, x is the logarithm of the number, given number y to the base e. E power x is also known as anti-log of x to the base e. That means y is equal to anti-log of x to the base e. That is how we can read. Common logarithms of a given number y to the base 10 is the number x to which the base 10 is to be raised to make it equal to the given number. So this is how we write it. It is just a reminder. Once again it is given so that several times if we are able to see, we will be able to remember. Now 10 power x is known as anti-log of x to the base 10. So common logarithms of a given number y to the base 10 is the number x to which the base 10 is to be raised to make it equal to the given number y is generally written as log of y equal to x. So we can read this as log of y. The y is kept in the bracket so that we can read it as log of y. That means y is equal to 10 power x. So 10 power x is known as anti-log of x to the base 10. That means y is equal to anti-log of x to the base 10. In case of natural logarithm, the base is changed from 10 to e. So natural logarithm of a given number y to the base e is the number x to which the base e is to be raised to make it equal to the given number y. It is generally written like this. It is written as ln of y. So it is, when ln is written, it is called natural logarithm. And if you write log, it is called common logarithm. So if ln y is equal to x, then y is e power x here. So e power x is anti-log of x to the base a. So if ln of y is equal to x, then y is equal to anti-log of x to the base e. The log of y to the base e is equal to x is generally written as ln of y is equal to x, and therefore y is equal to e power x. This is some of the mathematics books, particularly those printed in England, will use the symbol ln for natural logarithm and log for common logarithm. So when you write log, it is common logarithm, and anti-logarithm means it is 10 power x. Let us understand by taking some examples. The log of 1000 to the base 10, it is 3. Why it is 3? Because when we write this logarithm of 1000 to base 10 using this notation, log of log of 1000 is equal to 3, it means that the 1000 is equal to 10 cube. So then therefore the log of 1000 in common logarithm is 3. So 10 power x is the anti-log of x to the base 10. So logarithm of 1 lakh, there are 5 zeros there, to the base 10 is 5. It is because when we write log of 1 lakh is equal to 5, then it means this 1 lakh is equal to 10 power 5. So therefore 5 is the logarithm of 1 lakh. So 10 power 5 means anti-log of 5 to the base 10. Let us take another example. It is like log of 100 to the base 10. So this will be equal to 2. Again, the reason is easy to identify. Log of 100 is equal to 2 means 100 is equal to 10 to the power of that 2. So 10 to the power of 2 is anti-log of 2 to the base 10. Another example, logarithm of 10 to the base 10 is 1. It is written as log of 10, which is equal to 1, because this 10 must be equal to 10 to the power of that number, which is 10 power 1. So 10 power 1 is the anti-log of 1 to the base 10. The logarithm of 1 must be 0, because if you write log of 1 is equal to 0, then 1 becomes equal to 10 to the power of that 0. So 10 to the power of 0 is 1. So therefore logarithm of 1 is 0. So 10 power 0 is the anti-log of 0 to the base 10. Natural logarithm. So natural logarithm, the base is e. It is generally written as ln y. When you write log, it is generally for common logarithm. When you write ln, it is for the natural logarithm. So in that case, y is equal to e power x. Here e power x is the anti-log of x to the base e. Value of e is 2.71828, 71828, 4590, 3, 4, 5, etc. It continues. Let us take an example. Log of 2 to the base e. It is equal to 0.693. It is generally written as ln of 2, and that means 2 is equal to e to the power of 0.693. So e to the power of 0.693 is known as antilog of 0.693 to the base e. Similarly, log 3 is equal to 1.0986. So this is written as ln of 3, and 3 is equal to e power 1.0986. e to the power of 1.0986 is known as antilog of 1.0986 with to the base e. Say log 1 to the base e is 0. It is written as ln of 1, and 1 means we have to write it as e to the power of that number 0, which means 1. So e power 0 is the antilog of 0 to the base e. So logarithm of 1 to any base is always 0. So this is another example where we take log of e to the base e, it will be 1, because this e is equal to this e to the power of 1. So that is written here. E power 1 is known as antilog of 1 to the base e. Log 0 to the base e is minus infinity. It is written as ln of 0. So e power minus infinity means it is 1 upon e to the power of infinity. Now, infinity itself is read as, the symbol is read as infinity. It is not a number, but it is just a symbol to indicate a very large value. So, log 0 is minus infinity means the 0 is equal to e to the power of minus infinity. That means 1 upon e power infinity. Now, infinity is a large number, so e to the power of infinity is still a very large number, and reciprocal of that very large number will be a very small number, and it can be nearer to 0. So let us see some examples. Say 1 by 10 is 0.1. 1 by 100 is 0.01. 1 by 1000 is 0.001. 1 by 10,000 is 0.0001. Like that, if we increase the denominator to a large value in the left hand side of this equation, then the value of the reciprocal on the right hand side of the equation becomes smaller and smaller, and it will be more nearer to 0 as the denominator in the left hand side becomes larger and larger. In scientific calculators, there are buttons with labels such as either log of x, log of x, or ln x, or some calculators will have only log or ln, and there will be corresponding 10 power x and e power x buttons also. So here log button, if we press, that means we are using common logarithm with base 10, and anti-log will be 10 power x button. Similarly, if we are using natural logarithm, then with the button with ln is pressed, and the antilog is given by the button with label e power x. So it is better to state clearly when we are writing something message for anybody or in the answer book of any examination that log y to the base is written as log of y and log y to the base e is written as ln y, so that information is made clear, correct and complete to the viewers. Change of base from e to 10. So logarithm of x to the base e is equal to, can be written as this x we write separately here, log of x to the base 10, and denominator write this e, log of e to the base 10. Now log of e to the base 10, if we take, it comes to 0.4343 and 1 upon 0.4343 will be like 2.303. So if you want to take logarithm of a number x to the base e, then we can use common logarithm table, find the log of x to the base 10 and multiply it by 2.303, so that we will get the log of x to the base e. Some important results are, the purpose of using the logarithm is to avoid multiplication and division. Instead of that, we can use only addition and subtraction. Generally, addition is done correctly by many people, but when subtraction comes, there will be difficulty. It is because of the simple reason that subtraction means sometimes it involves borrowing from neighboring digit. It is the common observation that anything that is borrowed will not be returned at all. You borrow the books, you will not return. You borrow the pen, you will not return. You will borrow money, it will not be returned. So, therefore, even the business people never do subtraction at all. They only know how to add numbers. They do not know really how to subtract numbers, because whenever they try to do subtraction, they will forget what was borrowed from the previous digit, and that results in paying to the customer more change than what they should give. So therefore, if we purchase a pen for 7 rupees and we give rupees 10 currency note, then instead of subtracting 7 from 3, he will say adding 1, 7 will become 8, adding another 1, it becomes 9, adding another 1, it becomes 10. Like that, he will count and give that 3 rupees change, because he don't want to take the risk of subtracting and forgetting what is borrowed and pay the customer more money than what is actually to be paid back. So, logarithm is a method to do the multiplication of two given numbers by using addition operation. Similarly, division of two numbers can be done if we know how to subtract one number from another number. Similarly, raising to a power. If something is raised to a certain power, then that can be found converting that problem into a product form like logarithm of m to the power of n to the base a is equal to n log m to the base a. So this one is a product of n as well as log of m to the base a. That can be again, we can use this formula and convert it into a addition problem also. So here, if you know the multiplication, then you can multiply this number by this n and then go for taking antilog. Similarly, this is a formula where it says logarithm of number b to the base a is 1 upon logarithm of a to the base b. Let us see some examples. See, we want to multiply 2 and 3. Although we know that 2 into 3 is equal to 6, we will see how to do using the logarithms. This logarithm of 2 multiplied by 3 to the base a, base 10, can be written as log of 2 to the base 10 plus log of 3 to the base 10. Now log of 2 to the base 10 is 0.3010 and log of 3 to the base 10 is 0.4771. Now if we add these two, it becomes 0.7781, which is the logarithm of 2 multiplied by 3 to the base 10. Now what it means is 2 into 3 we want, it can be written as 10 to the power of 0.7781. Now 10 to the power of 0.7781 is antilog of 0.7781 to the base 10 and it comes out to 5.9993. Actually, result should have been 6. So here we use what is called a 4-figure logarithm table. Accordingly, the digits here, the numbers coming after the 4th digit, they are not shown there at all. So there will be rounding off errors and truncation errors, and therefore we may not get the exact answer, but if problem is solved using the logarithm table by all students in the examination, then everybody will get the same answer. Also, there are mathematical tables or logarithm tables which are known as 7-digit logarithm tables. If we use that one, we can get the answer correct to that 7 digits decimal place accuracy. But nowadays, the scientific calculators are available. They will contain the LOG button as well as LN button. Now depending on whether we are using common logarithm or natural logarithm, we can press the button LOG or LN as required, and antilog will be available by pressing either 10 power x button in case of base 10 or e power x button in case of natural logarithm. Let us take another problem like log of 2 by 3 to the base 10. Now division problem becomes a subtraction after taking logarithm. So this can be written as log of 3 to the base 10 minus log of 2 to the base 10. Log of 3 by 2 to the base 10 therefore becomes equal to log of 3 to the base 10 is 0.4771 minus log of 2 to the base 10 is 0.3010. So subtracting 0.3010 from 0.4771, we get log of 3 by 2 to the base 10 is equal to 0.1761. Now, that means 3 by 2 must be equal to 10 to the power of 0.1761. So, when we calculate using the 10 power x button in the scientific calculator, we get the answer as 1.5000, which is correct because left hand side is 3 by 2, right hand side also it should become 3 by 2. In this case, there is a perfect matching. So, if we use a 4-figure logarithm table, the answers will be correct up to 4th decimal place. And if we use a 7-digit logarithm table, then results will be correct up to 7 significant digits. This is an example in which we are raising the power of a given number. Now, this raising of a number to a given power can be converted into a product problem or multiplication problem by using the laws of logarithm. That is, log of 3 to the power of 2 to the base 10 can be written as 2 multiplied by log of 3 to the base 10. So, log of 3 to the power 2 to the base 10 becomes 2 will be as it is multiplied by log of 3 to the base 10, which we have used in the previous problem also, is 0.4771. So, if you multiply these two, you will get 0.95 volt. That means the 3 to the power of 2 must be equal to 10 to the power of this number. And when you substitute, it comes like 8.9991. That is, 3 square should have been 9. But here, due to the truncation and round off errors, the answer is not coming as exact, but it comes very near to exact values. Here is an example where we want to take log of e to the base 10. So it can be converted into log of e to the base a for this numerator, and this is log of 10 to the base e. That means we are changing the base from 10 to e. Now, log of any number to the same base is always 1. So numerator becomes 1 there because e is equal to e to the power 1. Like that it will come. Whereas log of 10 to the base a is like 2.3026. So 1 upon this will be 0.4343. That is log of e to the base 10. Natural logarithm of a given number y to the base e is the number x to which the base e is to be raised to make it equal to the given number y. It is generally written as ln of y is equal to x and y is equal to e power x. E power x is the antilog of y, antilog of rather it is x to the base e. From these examples of constants, it is clear that constants are actually written using the value expressed in numbers. However, constant may be represented by using the letters from the English language or even the letters from Greek language. The examples are small letter G, small letter E, and Greek letter Y. The use of letters to represent constants simplifies the process of writing the calculation formulas. In the textbook on differential calculus, in the chapter on limits and continuity, it is not uncommon to come across statements such as the constants are generally represented by using the letters in the beginning of the alphabets in the English language, such as A, B, C, dot, 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 like that. As a general rule, we will extend this idea of representing constants starting from the letter A, going up to letter N, that is A, B, C, D, E, F, G, H, I, J, K, L, M, and N. We use them for representing constants. So, the use of letters A, B, C, D, E, F, G, H, I, J, K, L, M, N for representing constants. This is not a rule that is actually engraved on a hard polished jet black granite stone. That means we can use any other letter also if we wish by defining what that letter means in the beginning of the problem. The actual letter used other than the general practice are always defined before their first use in writing any information. Variables are letters which are represented by the letters at the end of the alphabet of the English language. Generally used variables are dot 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 XYZ. That means the letters at the ending XYZ are there. So what we will do, we will add the additional letters before the XYZ. So accordingly, we can use letters like PQR, STU, VW, XYZ to represent variables in any given problem. So what we have done is, starting from letter A up to L, M, and N, we used them for constants. P onwards, we are using for variables. What we have not used is the letter O. Letter O we will not use either for representing constants or for representing variables, because 0 can be confused with O. To avoid that, the O is not used either to represent a constant or to represent a variable. So here afterwards, as a general rule, we will use A, B, C, D, E, F, G, H, I, J, K, L, M, and N for representing constants in all expressions and equations. Similarly, we try to use the letters PQR, STU, VWX, YZ to represent variables in a given problem. Again, this is not a rule that is engraved on hard, polished jet black granite stone. Actual letter used, if it is other than the general practice stated earlier, are always defined first before their first use in the problem. Now, we have to understand the difference between the algebra and arithmetic. Actually, this one is correct difference. It is difficult to find from people who have studied mathematics also. There was an occasion where in a village primary school, the students study only up to standard 1 to 4. Then afterwards, the students will not continue the middle school, which is from standard 5 upwards, because they have to go to neighboring village for attending the classes in the middle school. So instead, the parents send their children for grazing the cattle in the field. It was a particular Saturday. Saturday, the classes are only half a day from 8 a.m. to 11 a.m. So, when I was returning from the class, between our village and the village in which the middle school is there is a tank, water tank. It is a water body which is generally full and overflowing during rainy seasons, and it will be completely dry during the summer season. So the bank of the tank is a one way, so that means it is narrow, and either a vehicle can go from one end to the other end, or a vehicle can come from other end to the one end, but they cannot cross on the way in between. So normally people stop before entering the road on the bank and signal the any vehicle or a bullock cart on the other end not to come or to come, so that only one vehicle will pass on the road. I was approximately at the middle of the road, and one of the parents of a classmate in primary school, his name was Siddhu. So Siddhu asked me a question. Swami, ಒಂದರಲ್ಲಿ ಎರಡು ಹೋದರೆ ಎಷ್ಟು? That means how much is by subtracting 2 from 1. So in middle school, actually the algebra was introduced, and there it was learned that any number can be subtracted from any other number. So what we do is we subtract the small number from the big number and keep the sign of the big number as the answer. So 1 minus 2, I told him it is minus 1. He just laughed on hearing my answer. Then he said, Swami, ಪ್ರೈಮರಿ ಸ್ಕೂಲ್ ಆದಮೇಲೆ ಮುಂದಕ್ಕೆ ನೀವು ಎಷ್ಟು ಓದಿದ್ರು ಒಂದೇ, ಬಿಟ್ಟರು ಒಂದೇ. ದಟ್ ಮೀನ್ಸ್ all higher education is totally useless, because if you have 10 rupees in your pocket, can you give me 20 rupees? It is not possible. So that is how any higher education beyond 4th standard in primary is useless, and therefore they use their children to assist in agricultural work like grazing the cattle, shifting the material from one place to another place, carrying lunch for the parents who are working in the field, etc. like that. So maybe that one can be considered as an important difference between arithmetic and algebra. That means in arithmetic, subtraction of a big number from a small number is a meaningless operation. So that is what is quoted here. If somebody has rupees 10 in his pocket, then he cannot give rupees 20 to somebody else. In algebra, subtraction of a big number from a small number is a meaningful operation. That is in algebra. Example, 10 minus 10 means we write minus 10. 10 minus 10 means we write 0. 20 minus 10 means we write 10. That means answers can be negative, positive, or even 0. 0 is called an unsigned quantity. Now onwards, we'll be using only algebra. What it means is we have to give importance to positive and negative sign of every piece of data that is used in the problem, and we have to remember the rules that positive numbers when multiplied together they give the positive answer. Similarly, two negative numbers when multiplied it gives the positive number. If one is positive and another is negative, does not matter whether first is positive, second negative, or first is negative, second positive, the result will be negative answer. So, this importance of sign of the quantities involved in the calculations and the results of multiplying quantities with different signs, either positive or negative, have to be carefully applied. So we will study only algebra. The algebraic operations commonly we do include addition, subtraction, multiplication, division, power, and roots. For this purpose, we use what are called algebraic operators. Operators are symbols, mathematical symbols used to indicate the particular type of operation. For example, addition of two quantities, we use a plus sign between the quantities. Subtraction of one from the other, we use the minus sign. Multiplication of one by another one. So either we use this type of a cross mark, or sometimes we use a dot mark. Sometimes computer character star is used, or sometimes we simply write the numbers. If it is algebra like A and B items are there, AB means we treat it as positive only. So we will not use any of these symbols also. Division, either this symbol or this is used, or even we use a numerator divide denominator form also. Powers are like square, cube, or any power n, and roots are square root, cube root, fourth root, etc. for nth root. So algebraic expressions. So example, if we take mx plus c is an algebraic expression. Here you see all the rules what you have defined have been used. That means as per the rules, the c and m are constants, x is the variable, because x is coming at the end of the alphabet and m and c are coming in the beginning of the alphabet, keeping the O as the reference point. Now, between m and x, there is neither dot mark nor cross mark, but we remember mx means it is m multiplied by x, and therefore we are not using any algebraic operator between these two. So plus is the another algebraic operator. Now another example of algebraic expression is ax square plus bx plus c. Now here we know between a and x square there is no multiplication sign or dot, but we remember that a into x square means it is written as ax square, and it is a product of a and x square. Similarly, bx means it is the product b into x. So the plus signs are given here, but it depends on what are the signs of ABC as well as X used, because while evaluating the value of such expressions, it is very necessary to consider the positive sign and negative sign of individual quantities. Algebraic equations. Equations will have a equal to sign, and one side we can have a variable to be determined. Other side there will be expression which after evaluation will give the value of the variable on the left side. Here example y is equal to mx plus c is one example. Y is equal to ax square plus bx plus c is another example. So actually, if we are solving only one problem at a time, then generally we use x and y like that. So y is equal to mx plus c, y is equal to ax square plus bx plus c, like that can be used if we are solving one problem at a time. But if we have more than one problem, then it is necessary to use different variables on the left of the equal to sign and for every different expression on the right side. Accordingly, if we use y for representing the equation y is equal to mx plus c, where mx plus c is the algebraic expression, we know that m and c are constants here, therefore y depends only on this x. So we can write like this. This is read as y is equal to f of x. That means y depends only on the value of x used in the expression. Now, if we have another problem like ax square plus bx plus c, then we will call this by another letter other than y, say as z is equal to ax square plus bx plus c, and z is a function of another variable x. So here f of x means it is like mx plus c, and g of x means it is ax square plus gx plus c. Now this letter f and this letter g are something like names of the functions, algebraic functions. These are single letter names. So for each type of a function, we will use a different name here, function name. For example, y is small f of x is written here, whereas z is small g of x is written. So fx means it is mx plus c in this problem, and gx means it is ax square plus bx plus c in this problem. Value of a function y is equal to f of x when x is equal to a is written as y is equal to f of a. That means when you write f of a, it is value of the f of x. So this x value we have to replace by the a value. That is when x is exactly equal to a. Example, y is equal to 2x plus 5. This is a function of x because 2 and 5 are constants. X is the variable. So by giving different value for x, we can find the corresponding value of y. So when y is equal to 2x, if you write x is equal to 5, then 2 into 5 will be 10, plus 5 will be 15. So answer f of 5 will become 15. So value of f of x when x is equal to a is written as f of a. F of a is nothing but value of f of x when x is equal to a. So this is another example. Suppose y is equal to 2x square plus 5x minus 12. This is also a function of x. But here x is at these two places. Here there is squared, here that is a single, x is there. So this is a product of 5 and x. This is a product of 2 into x square. So if you substitute x is equal to 5, then it is 2 into 5 square plus 5 into 5 minus 12. So 2 into 5 square will give 50 because 5 square is 25, 25 into 2 is 50, plus 5 into 5 is 25, So that becomes 75, and we subtract 12, giving 63 as the value of 1. So when x is equal to 5, y becomes 63. That is y is equal to f of 5. Means value of f of x when x is equal to 5. Example, let us take a problem like this. Y is equal to f of x is x square minus 4 by x minus 2. Now, this x square minus 4 can be written as x square minus 2 square. Now, suppose we want to find f0, that means value of this f of x when x is exactly equal to 0. So we substitute wherever x is on the right hand side equal to 0. So f of 0 becomes 0 minus 2 square is 4 divided by 0 minus 2. So that means minus 4 by minus 2 will become plus 2. Similarly, if you want f of 1, then that x will be replaced by 1 here and x will be replaced by 1 here. So we get 1 square is 1 minus 4 by 1 minus 2. So this will give minus 3 and this is minus 1. Therefore, we get the answer 3. So f of 1 is 3, f of 0 is 2. So, suppose we find f of 3 now. So, 3 square will become 9 there, minus 4 divided by 3 minus 2. So, 9 minus 4 will give 5, 3 minus 2 will be 1. So, 5 by 1 will be 5. Similarly, we can find what is f of 4. F of 4 is 4 square, which is 16 minus 4 divided by, it is 4 minus 2, that is 2. So 16 minus 4 is 12 divided by 2 will become 6. So f of 4 is equal to 6. Now we take the another example where we want to find what is f of 2 in this problem. So f of 2 means 2 square minus 4 divided by 2 minus 2. So that becomes 4 minus 4 by 2 minus 2, which is equal to 0 by 0. Now 0 by 0 is called as indeterminate form. So here it is important to note that x divided by 0 is called as infinity or very large number and pronounced as infinity. This is the symbol written for infinity. This is only if x is not equal to 0. Similarly, 0 divided by x, where x is any quantity, is 0, provided this x itself is not 0. So, indeterminate means a value cannot be determined, but it need not be infinite always. So, whenever you come across 0 by 0, it is called indeterminate form. And x by 0 is infinity if x is not equal to 0, and 0 by x is 0 if x is not 0. So, if it is 0 here, 0 by 0 becomes indeterminate. Similarly, if x becomes 0 here, 0 by 0 becomes indeterminate. So, in the next class, we will take up problems on finding the limits. Now, we are able to find the value of the function, and we saw several examples where given any value of x, we can find the corresponding value of y, but there are some problems like the problem at the end that we have taken where the value of f of 2 we could not evaluate at all, because we got it as 0 by 0 or indeterminate form. So we will come across several mathematical equations where either it is possible to find the value of the function for all values of x which we are interested, or there may be problems in which it may not be possible to find the value of y of a given function y is equal to f of x for all values of x. Maybe at some points we may not be able to find the value, and at those points value need not be a very large number also, but they cannot be determined. So we will continue this lesson in the next class, where we will be able to find method of determining what is known as limit of a function when value of a function cannot be determined, or value of a function when evaluated becomes an indeterminate form like 0 by 0. Then we will have method of determining not the value but what are known as limits of the function. So there may be several points where this indeterminate form comes when determining the value of function, or there may be only one particular value at which the value of the function may take indeterminate form. So these things and corresponding examples we will continue on the next Saturday. Same time, 6 p.m. to 8 p.m. So you are welcome to join us in the next class on next Saturday, because this series of lectures or discussions through virtual mode through Zoom will be available on all Saturdays between 6 p.m. and 9 p.m. So maybe after few classes we will be able to add additional virtual lessons on the other days of the week also, because we wish to cover at least 1,000 lessons in 1 year period, which amounts to something like at least there should be 2 or 3 lessons every day. But you see, there is large amount of effort, time is required to plan, formatting, contents, information, etc., arranging information in a simplest possible form, so that although we have spent several sleepless nights for understanding the subjects in those days when not many books were available, and because of coming from remote areas, we had no access to people who knew the subject and get any clarification from them. So, but today, as just one of our teacher told in the middle school, that is while studying in the 5th class, a teacher by name Praneshacharya, he told us when they are asking questions, answers must be given immediately without thinking, which he was telling that you must have answers for all problems at your fingertips. Maybe in those days there were what was meant by the teacher as fingertips, we do not know. But today it has become a reality, because today everything is available at fingertips. So what is important is, it is not that everything is available in our fingertips, but we should look for particular thing which we want and whether it can help us. And that is where we are conducting this series of lessons under the banner of Padma Shri Dr. SR Valluri Memorial Lecture Series, which is currently, to start with, is kept on all Saturdays between 6 and 8, and gradually, as we produce more and more lessons, the presentation material, etc., there will be several such things even on a daily basis, or the frequency will be increased, so that one day, I repeat, one day we will be able to complete something like 1,000 such sessions in a period of 1 year. So, till next Saturday, you please go through the same lessons. It will be available in the YouTube. You can go through it, watch it several times as needed in individual cases, and go through and try to understand the information that is given in this presentation, so that you will be ready to follow the subsequent lessons in this one, so that at the end of the complete sequence of lessons in mathematics, you will be an expert in mathematics, and you will be able to say that mathematics is easy to learn, easy to remember, easy to practice, and easy to score marks in the qualifying examinations. So, for the time being, let us say thank you, viewers, and goodbye. If you have any questions, you are welcome to write it to x9t9@yahoo.com, so that those things can be answered in the next session. Also, those of you who are interested in preparing and presenting the material in the simplest possible way, in the shortest possible time, so that your efforts will be useful for somebody who will view your presentations either online or offline. They will get some benefit out of your lecture. Plus, you will also get opportunity to teach while learning. In fact, the best method of learning any subject is to start teaching it, because when we want to teach, it is necessary to think over all types of students who will come and their background with different heterogeneous group, so that how to make everybody understand the lessons correctly, clearly, and completely. And therefore, we will have to think and study more and more and more. Therefore, it is to become a teacher, you have to become a student for life. That means study, study, study. Simplify, simplify, simplify. Standardize, standardize, standardize. And repeat this 9S principle repeatedly, so that things become clear not only to you but to the viewers of your program through appropriate media. So thank you and goodbye.